In this problem, I'm going to show you how to use the sum or difference formula to find cosine of 165 degrees. I may be doing it a little bit differently than others would, but what I like to do is use reference angles. And really, we want to focus on using 30 degrees, 45 degrees, and 60 degrees. It's kind of the only ones that we probably have memorized for sine and cosine. And we want to just play around with those and not mess with any bigger angles, unless maybe it's a 90 degrees or something like that. So what I mean by using reference angles is, let's first go ahead and place 165. It's going to be between 90 and 180 degrees. So just drawing it in here, it's going to be somewhere a little bit closer to 180, quite a bit closer. But 165 degrees will get us that far. And then if we draw in our reference angle, it's going to be this red angle that connects into the x-axis. It's always into the x-axis. So I'm going to go ahead and call that theta bar. To calculate theta bar, what we're going to do is start with the larger of these two angles that make up our reference angle. That would be the 180 degrees. And we're going to go ahead and subtract away the 165 degrees. What this is going to leave us with is a 15-degree reference angle. What we'd like to do is go ahead and plug that in and replace our cosine of 165 degrees is going to be the same thing as cosine of 15 degrees. However, we got to be careful here. Whenever we fill in a reference angle, we have to be careful about which quadrant the original angle was in. So 165 degrees fit us into the second quadrant. Now I like using the phrase all students take calculus to help me remember what's positive in which quadrant. So in our case, we were in the second quadrant, so that means sine was positive, but that also means that cosine and tangent are negative in the second quadrant. So I also need to include a negative right in front as soon as we plug in the reference angle. All right, now we're in business, right? 15 degrees, we want to come up with a pair of 30, 45, and 60 that either add together and make 15, not going to happen, or subtract and make 15 degrees. So our two options, and we do have two here, we could use 60 and 45 because 60 minus 45 makes 15. Or we could use 30 and 45 because 45 minus 30 is the same thing as 15 as well. All right, so it doesn't really matter which direction we go on this. I'm going to show you both ways just so we're sure exactly, we're going to get to equivalent answers. So let's go ahead and jump right in here. All right, we're going to use the difference formula, and we can replace on the inside here, we'll have the cosine still as our function, but we can replace that with, let's do 60 minus 15 first, or 60 minus 45 first. Oh, let's go ahead and rewrite that so you can see it very clearly. We're going to rewrite this. 15 degrees is 60 degrees minus 45 degrees. So in this case, what we're going to do is we're going to, wherever we see an alpha, we're going to replace it with a 60. So alpha is over here in our formula, alpha is over here in our formula. And then wherever we see a beta in our formula, we're going to replace it with a 45. So beta, beta, beta goes in here. So hopefully this makes sense. I'll try to color code everything as we go. Don't forget we need to bring this negative along out in front because we use the reference angle. So negative goes out in front. We're going to replace this, go cosine of, instead of alpha, remember we said 60 degrees goes in here, multiplied by cosine of, instead of beta, remember we're going to put 45 inside of there. And then from there, we're going to go ahead and add sine of alpha. Again, 60 goes in there, multiplied by sine of beta. Beta again is 45 degrees as I'm kind of running out of space here. All right, but we're actually in a pretty good place after we've filled in everything. So from here, if we want to reduce down and get a better answer, what I'll do is go ahead and bring that negative along from the outside. And then we can evaluate cosine of 60 degrees. Hopefully the nice known value here is going to be 1/2 multiplied by cosine of 45, square root of 2 over 2, plus sine of 60. It's going to be square root of 3 over 2, multiplied by sine of 45, square root of 2 over 2. All right, this will reduce down a little bit further. We can bring the negative to the inside. We'll do that in a second. But we currently have square root of 2 over 4 plus square root of 6 over 4 as we multiply numerators, multiply denominators. I'm going to go ahead and say the negative is out in front of a big fraction and leave this as common denominator of 4 comes along. We'll use square root of 2 plus square root of 6 in our numerator for the final answer. But before we get done with this video, let's go ahead and also show you how we could have used 45 and 30 if we wanted to instead. Okay, so remember where we were. We were right here. We can replace this with negative cosine of, I'm going to go ahead and color code this as we go. I'm going to use 45 this time as my alpha, minus 30 as my beta. And color code that as beta. Goes with the exact same formula that we had up here above. So I'm going to go ahead and fill this in appropriately. I'm running out of screen real estate, so bear with me. All right, the negative from in front comes along. Then on the inside, remember we had cosine times cosine plus sine times sine. We just got to get things lined up in the right places. So remember, 45 goes in for alpha in our formula. Here is another alpha. And 30 is going to go in for our beta. All right, from here, it really is just a matter of simplify this down. The negative will come out. Then we go square root of 2 over 2, multiplied by cosine of 30, which is square root of 3 over 2, plus sine of 45, square root of 2 over 2, multiplied by sine of 30, which works out to be 1/2. Bring the negative along, multiply numerators, multiply denominators, plus multiply numerators, multiply denominators. And we can wrap this up by negative's going to go in front of our big fraction, keep the common denominator, go ahead and add those numerators together. All right, as you'll note, should be the exact same solution. It's in a different order, but that's okay. This solution that we found using 60 and 45 as a subtraction, or this one with our difference using 45 minus 30 to make our 15 degrees. So I hope this helps out as you're working through these. I really would encourage you, go back to 30, 45, and 60 whenever possible on these by first using that reference angle, and you'll do great on them. All right, hope this helps out. Good luck.